Okay, guys, this is linear programming. In linear programming problems, step one, you need to be able to write equations. Then you need to graph the equations and shade the equations. Um, Actually, they're inequalities, not equations, because they're less thans and greater thans. Then step three, you're going to solve for each vertex. Now, you may need to use substitution, elimination, or sometimes it's just pretty plain to see what those vertices are. And then step four, you need to optimize each situation. Optimization means either find a maximum or a minimum. In this case, it's called a maximum. You're looking for a maximum profit. So Kate grows and sells tomatoes and green beans. I'm going to let you pause the video and um, read through it and try to set up the equations. So I'm going to click pause right now and give you a few seconds to do the same. So please pause this video. Okay, so after pausing the video, you should have read through it and try to figure out what the equations are about. Just like in our story problems, we want to write an equation that has to deal with the same units. When I say units, I'm talking about the label. In this case, it costs $1 to grow tomatoes, and it takes 1 square yard of land. And it costs $3 to grow green beans. That takes 6 square yards of land. Kate has a budget of $15, 24 yards. So anyway, there's dollars and yards. So I'm going to do one equation that deals with all the dollars. So in this case, here's my dollar equation. $1 for a bushel of tomatoes plus $3 for a bushel of green beans. I'm going to use G for green beans. And then finally, that should equal the total amount of money, which she has 15 bucks. But she doesn't have to spend all of that. That's just what she has as a budget. So we have to stay at or below that budget. So I'm going to put less than or equal to. So there's my money equation. Um, T being tomatoes, the number of tomato plants, and then G being the number of green beans. Second equation should deal with the total amount of land she has. In this case, she has 24 square yards of land available. So that's our total. We want to stay at or below 24. So let's use the information we have about yards of land. 1 square yard of land for tomatoes. So 1T plus how much for beans? I think it was 6, wasn't it? Yeah, 6 square yards for beans. 6 for green beans, and we have to stay under 24. I don't see any other constraints, but it does tell us the profit. Now, the profit equation works a little different. We also call this a profit function. Function because they're working together. And we're going to get more into functions as in a couple chapters here, but we're going to create what's called a profit function. The profit is, I use a capital P, and then I use the two letters that I'm dealing with. In this case, T's and G's. I don't care which way you put them, G's and T's or T's and G's, it doesn't matter. I'm going to say T, comma, G. So what this stands for is the profit that I get from tomatoes and green beans is, well, what was that equation? $1 profit from tomatoes, so we only make $1 profit from tomatoes, but we add to that the $4 profit from green beans. And you should make some money on the green beans because they take more space, they cost more to grow, all of that. Okay, so this is our profit equation. We're going to maximize that. We're going to find out which of our ordered pairs create the best amount of money for us. We're going to maximize. So I'm going to start graphing this puppy. Now when I graph it, I obviously want to stay in the first quadrant. And the answer to why do I want to stay in the first quadrant? It's because you can't grow negative tomato plants or negative green bean plants. So everything's going to be in the first quadrant. Now before I even start making my tick marks or graphing, you have to do the intercepts, the x-intercepts and the y-intercepts. In this case, I put tomatoes first, and then tomatoes with an E. Sometimes they have E's, sometimes they don't. It doesn't matter. Anyway, tomatoes with an E or green beans on the y-axis. So I'm going to find a tomato intercept first. So as I cover this up, imagine my marker is my finger. I cover it up. My tomato intercept is 15. So I know my T's have to go out to at least 15. I'm just going to write that over here so I don't forget it. My green bean intercept is 5. So right now I would say my tick marks need to go 15 on the T and 5 on the green, beans. Let's go down here, this equation. Tomato intercept, ooh, is 24. So that means my tomato intercept will have to be a lot further than my tomato intercept up here. And then down here, my green bean intercept is 4. So my green bean is 4. Now, when I look at these numbers, I know on my tomato axis I have to go out to 24. What I'm going to do, I'm going to go by 5. 5, 10, 15, 20, 25. So I just picked the biggest numbers, 24, right? So going by 5s makes it big enough that I can see the graph. So you want to make your graph as big as possible. Here, which is bigger, 4 or 5? In this case, green bean intercepted 5, so I'm just going to go by 1s up here. 1, 2, 3, 4. Oops, that one was a little small. 5. And then there's my green bean intercepts. Now I'm going to actually graph them. Tomato intercept, we said was 15. Green bean was 5. Here we go. 15, 5. Get your straight edge out. You may want to use a nice long ruler for this one since your graphs might be pretty big. Boom. And 0, 0 is less than 15. That is true, so I'm going to shade towards 0, 0. That would be this way. Okay, let's do the second equation. Tomato intercept is 24. Put a dot at 24. My green bean intercept is 4. Dot at 4. I'm going to get my straight edge out and connect the dots. Shade 0, 0 is less than 25. That's true. So I shade down. So if I look at my technically quadruple shaded region, that would be here. And why do I say quadruple? It's because obviously I can't be negative, so my tomatoes have to be greater than 0, my green beans have to be greater than 0. So there's my quadruple shaded region, because I was shaded this way, 3, 4 equations. Now I got to find all my corner points. Now the corner points of the shaded region are going to maximize the function, okay? For example, that's a corner point. That's a corner point. That's a corner point. And that's a corner point. It's quadrilateral, so I got 4 corner points. Now I'm going to figure out what those 4 corner points are. Some of them very easy, some of them not so easy. And once again, the corner points will optimize, which means maximize or minimize our function. So first of all, 0, 0. I'm going to write that over here. Now, if I make 0 tomato plants and 0 green bean plants, guess what? I'm not going to make any money. So that's going to be my minimum. So that's not going to be one that I'm going to actually check. But how about here? 15 tomato plants and 0 green bean plants. That's something I can make or grow. Up here, I could do 0 yards of tomatoes, 4 square yards of green beans. That'll make me some money. But is that the most? Probably not. So what I'm going to do is figure out what this point is. Now, to figure out this point, you're like, it looks like 1 tomato, no, 1 1/2 tomato, 1 1/4 tomatoes, and 3 green beans. I don't know what that point is. It looks like 1 1/4, but I can't guarantee it. So what I'm going to do, I'm going to find out where these 2 lines cross. Well, that's these 2 lines, so I'm going to do a elimination problem right up here. I'm going to take this top one times -1, so negative t minus 3g equals negative 15. And the bottom one I'm just going to rewrite. Equals 24. And let's see what the math says. Oops, that's supposed to be 6g. Cancels. 3g equals 9. G equals 3. So I knew my g was 3. I was right. That is something comma 3. My trick is I got to plug the 3 back in up here. So 3 times 3 is 9. Subtract that over. Would be 6. So this is, 6 comma 3. I forgot I was going by 5s, wasn't I? So if that's 5, this is probably 6. So 6 comma 3 is my last point. But I wouldn't have known that unless I did an elimination up here. So sometimes you might have to use elimination to find some of your corner points. Now, finally, we take each one of these points, we plug them in here, and we figure out which one makes us the most money. 0 tomatoes, 0 green beans, $0. Don't do it. 15 tomato plus 0 green beans. Guess what? You get 15 bucks. Yay! It's not worth your time. Plug in 0. 0 tomatoes. 4 times 4 would be $16 for green beans. You can make 16 bucks if you did 0 acres of or yards of tomatoes and 4 of green beans. Let's plug in 6 here. 6 square yards of tomatoes. 6 times 1 is 6. Plus 3 times 4 is 12. So, ooh, 18. Looks like that's the biggest amount there. So, to answer my question, what I would write is to maximize profit. Sorry, my writing's so bad, it's tough to do it on this thing. To maximize profit, Kate should plant 6 square yards of tomatoes, and what was it, 3? 3 square yards of green beans, and she will make $18 profit. Okay. Now, silly numbers, I understand, but in the end, this is a skill that you're using to do basically what's called linear programming. Linear programming is what engineers do. They make a lot of money doing it. They do this for companies. Now, they don't have story problems given to them. They go out and they create the story problems. They create the numbers from the data that the company gives them, and so it's a skill that you guys are going to need to be able to do. But think about your steps. Step 1, you write the equations. Step 2, you graph and shade the equations. Step 3, you solve for each corner point or each vertex. And step 4, plug those in and figure out which one gives you the most amount of money. Okay, that's your guys' job. Good luck.